We're now going to look at integrals involving roots, and these integrals can be a little bit tricky if you're not familiar with how to solve them. So we'll look at an example problem and talk about the different method to solving this integral. So the one method that you might be familiar with is doing a u substitution. And when we do a u substitution, this root might be the value that you select for u or u. And traditionally, after we select a u, we always do a du. But when we look at our du term, this doesn't really help us when substituting back into our original expression. And so what we want to do is perform the u substitution a little bit different. So we'll select this as our u, which is the whole denominator. And then what we'll do is rather than solve for du right away, we'll rearrange the terms to solve for x. So we'll get our expression x in terms of u. So you can see here we've rearranged this original u by subtracting this 2 to the left-hand side and then taking the square root or the square to get rid of the square root and then adding 4. And so what we're left with is the following term for x. The next step is to factor out this squared term, simplify, and what we're left with is the following expression for x. Now we can go ahead and solve for dx by taking the derivative of x, and we can get x in terms of u and dx in terms of u. And so what we'll do is then take this expression and plug it back into our original expression. And so rather than getting u and du and plugging it back in, we're going to get x and dx in terms of u and plug it back in. So you can see that's going to look like 7 over u. So this entire denominator is just going to transition to being u. And then this dx term is going to be our dx that we solved up here in terms of u and du. And so now this is very easy to solve. We can go ahead and simplify this 14u divided by u, which will just be 14. And then we'll have 28 over u for our second term. And so we can go ahead and take the integral of 14 and the integral of 28 over u and get the following expression. And our last step, as always, is to back substitute our u, which was our original denominator. And that will give us our solution to this example problem.